In our last video, we covered some basic technique for factoring polynomials, mainly quadratic polynomials. In this video, we want to talk about some advanced techniques for factoring polynomials through examples. Let's look at first example. X to the 6th plus 7x cubed minus 8. It is not a quadratic, but can we change it to a quadratic polynomial? If we view x cubed as a single variable, then we can write it as x cubed, then square plus 7x cubed minus 8. Now, if we replace x cubed by u, then we get a quadratic polynomial, u squared plus 7u minus 8. To factor this new polynomial, we need to break up the constant term -8 to two numbers. The product equals -8, the sum equals 7. They are -1 and 8. So that equals u minus 1, u plus 8. Now we replace back u by x cubed. X cubed. Here 1, I write it as 1 cubed by looking at the first formula. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And similarly, the second part, u equals x cubed, a equals 2 cubed. So applying the first formula, we get x minus 1 and x squared plus x times 1 plus 1 squared. Applying the second formula, take a as x, b as 2, we get x plus 2 times x squared plus x times 2 plus 2 squared. Clean up, we can get the final answer. X minus 1, x squared plus x plus 1. X plus 2 times x squared plus 2x plus 4. Now let's look at next example. Let's factor x to the 4th plus 4. It is not a quadratic polynomial, so no formulas can be applied. But we can write it as the sum of squares. x4 equals x squared and then square. 4 equals 2 squared. In order to make a perfect square and viewing x squared as a, 2 as b, we need to add a middle term, 2ab. So add 2a, here's x squared, b here is 2. Then you need to minus the same term to balance. 2x squared times 2. Now this first returns equals a perfect square. A plus b squared. A is x squared. B is 2. The last term is 4x squared, which can be written as 2x squared. Now we can apply the difference of squares. A squared minus b squared. So equals a, x squared plus 2. minus b, 2x, times a, x squared plus 2 plus b plus 2x. We can rewrite it to x squared minus 2x plus 2 times x squared plus 2x plus 2. Finally, let's factor a long polynomial. X squared plus 3xy plus 2y squared plus 4x plus 5y plus 3. After trying, you can see grouping doesn't work. But we can focus on the quadratic part. It can be factored. Find two numbers such that the sum equals 3, the product equals 2. They are 1 and 2. So the first part can be factored as x plus y times x plus 2y. But how can we generate 4x, 5y plus 3? We can put a number here, say m. Then using distributed rule, m times x get x term, m times y get y term. In order to get the constant 3, we also need another number, say n. So let's suppose we get the factoring like this. In order to determine the values of m and n, let's expand it. So x times x equals x squared, x times 2y, 2xy, x times n, nx. Now, y times x, xy, y times 2y, 2y squared, y times n, and y. Finally, m times x, mx, m times 2y, 2my, m times n, mn. Now we correct like terms. So x squared, 2xy plus xy, 3xy, 2y squared. So recover the quadratic part, x squared plus 3xy plus 2y squared. Now, for x term, nx, mx, we get m plus n x. For y, ny, 2my, so we get 2m plus n y and plus mn. Because their two polynomials are equal, so the corresponding coefficient should be equal. M plus n equals 4. Equals 4. And 2m plus n equals 5. And m times n equals 3. Now we denote that 1, 2, 3, 2 minus 1. So 2m minus n equals n. N minus n, 0. The right side, 5 minus 4, 1. So we get a value m as 1. Now, by the first equation, m plus n equals 4, but m equals 1. So 1 plus n equals 4. So n equals 3. Then we finally get the factoring form as x plus y plus n, which is 1 times x plus 2y plus n, which is 3. That's it.